Good afternoon, students. This is K. Prasad. Today we are discussing the database management system. In that database management system, we are in the UNIT-2. Here, in that UNIT-2, the first concept here is Introduction to SQL. These are the outlines topics. Overview of the SQL query language or structured query language, SQL data definition, basic structure of SQL queries, additional basic operations, set operations, null values, aggregate functions, nested subqueries, modification of the database. Now coming to the history of structured query language. Now initially the IBM SQL is developed. It is developed as a part of System R by the IBM laboratory, San Jose Research Laboratory, IBM San Jose Research Laboratory. It was renamed as Structured Query Language. Now it is popular query language. Now some of versions are available for initially from the initial stages. It is the ANSI and ISO standard SQL, that is SQL 86, SQL 89, SQL 92, SQL 1999. It is a Y2K compliant version, SQL 2003. Now coming to the parts of SQL. No, it is the data manipulation language. This is DML. It is called data manipulation language. It provides the ability to query information from the database and to insert tuples into, delete from, tuples from, and modify tuples in the database. It is completely data, extracting the data from the database, inserting the data into the database, and delete the data from the database. It is purely data based or data manipulation language. Now coming to the integrity. Now here is what is actually the integrity means. What type of data we are storing, what type of structure we are taking. For that purpose, we are using DDL, data definition language. The DDL includes commands for specifying integrity constraints, what type or how much amount of data we are taking and what range we are taking the data, etc. We are taking the data definition language. Now coming to the view definition. The DDL includes commands for defining views. Here base tables are available. From that base tables, many number of employees are working for that database. For that database, some of the employees are having, one employee is having one view and different employees are having different views like that. The large amounts of database are available. Different employees are viewing from different places. Now that is about the view. View is also available in the data definition language. Coming to the transaction control. What is some transactions we are performing? For example, what is actually a transaction means? We are specifying or we are sending some amount from one account to the another account. It is called as a transaction, which includes commands for specifying beginning and ending of the transactions. Whenever the transaction started and then completion of the transaction. The commands which are available to start the transaction and to end the transaction. Now this is called as the transaction control. Now coming to the embedded SQL and dynamic SQL. It defines how SQL statements can be embedded within general purpose programming languages. Normally we are having different programming languages like C, C++, Java, Python, etc. We can also embed these queries into the C programming language or Java. Now, by using embedded SQL as well as dynamic SQL. Now, coming to the authorization. Some of the authorizations we are performing whenever some intruders are there, those intruders can enter into database and then they can manipulate the things like that. So for that purpose, we are taking some authorization. We are taking for that authorization. We are using the authorization like we are providing some set of accesses for users. Now coming to the first one, data definition language. Now here the SQL data definition language allows the specification of information about relations. Here including the schema for each relation, the type of values associated with each attribute, and then the integrity constraints. Some constraints were specifying which type of values are taken for the attribute, etc. The set of indices to be maintained for each relation. Some indexing also maintained for every relation. Security and authorization information for every relation is also maintained in the data definition language. Now coming to the domain types in SQL. Different data items are also available. These are also called as the domain types. Here the first one is char of n. It can allocate the fixed number of n characters, fixed length character string with user specified length. Some char of 10, it can store 10, the maximum of 10 characters. Now coming to the varchar of n, it is similar to the char, but it is a variable length. If you take the maximum size is 10, if you store only 5 values, it can allocate the memories for only 5 values, not for the 10 values. But coming to the char, it can allocate the 10 values, 10 characters, the memory for 10 characters. That is the main difference between char as well as varchar. Now coming to the int, it is integer, a finite subset of integers that is machine dependent. Now, for example, in C language, we are discussing like 32,000 something. Here also it is completely machine dependent. Now coming to the numeric p comma d. For example, if you are using floating point numbers, for that floating point number purpose, we are taking numeric is the data type. Here some p comma d. How many decimal places, how many digits are there after the decimal point are specified by using the numeric or parameter d. Now coming to the another one, real double precision also specifying here, and then some float also is used to specify. Now coming to the how we are going to create the tables. Before performing any operations on the data, first of all, you have to create the tables. Now, the relational model, it is completely based on the set of tables. What type of tables we are creating, and based on the tables, we are performing any type of operations. Here, create table is the command which is used to create the tables. Now, the syntax for this one is create table, some relation, or a table name. Next, within the parenthesis, some attribute name 1 and domain 1, that is a data type, and then attribute 2 and domain for that purpose. And after completing all the attributes and domain name, you are specifying the integrity constraints. What type of integrity we are using? All are the integrity constraints are there. Those are specified. Here R is the name of the relation. Each AI is an attribute name in the relation of a relation R. DA is the data type or domain type, which is used to specify for all the attributes. Now coming to the same, for example, creating the table. Create a table. Here we are creating the Sailors table. For that purpose, we are taking create a table Sailors. SID is one attribute, number of 2. S name is another attribute, varchar of 20. It is not null, it is a constraint, integrity constraint, and completing rating. Number, age is also number. Here we are specifying the primary key. Already we discussed about what is the primary key and how we are going to specify the primary key, etc. Now coming to the integrity constraints in table, creating the table. Types of integrity constraints. Some types of integrity constraints are not null. If you specify the not null for any attribute means for that attribute you have to compulsory, you have to take any value. You don't want to put that column as a null value. No, compulsory you have to take some value for that attribute. That is not null. Now coming to the unique, if you take an attribute as a unique means it does not allow duplicate values. Duplicate values are not accepted for that attribute. That means for that constraint. Now coming to the primary key. It is the combination of not null and unique. If you consider or if you take an attribute as a primary key means that must be filled with some value and then it should be a unique value. For that purpose, we are taking the primary key. That primary key is used to distinguish one row from the another or one column from the another. That means one row from the another, one record from the another record. Now coming to the foreign key. Now for it is especially used for the purpose of relating two tables. A value of one relation may appear in another relation. Here it is especially used to refer the primary key which is available in the another table. Now these are the primary key as well as foreign key are especially used to creating the relations between one table and other tables. Now coming to the check constraint. Sometimes, for example, if you are entering internal marks, the maximum internal marks are 30 only. For that purpose, if you enter wrongly, that is 30 for the 35. Now, if you specify a check constraint for that attribute, it will check the value is below 30 or not. For it will indicate it. Now the entered value specified condition or specified constraint. For that purpose, we are using the check constraint. It will check the value which is available in particular something. Now, SQL prevents any update to the database that violates an integrity constraint. It can prevent the changes or updations that violating the constraints. Now coming to the next one is few more relation definitions. Now coming to the here, create a table boats. That is a boat ID, boat name, some color is there, that is not null is there, and finally it is completely at the last we are specifying the primary key of BID. Here we are considering BID as the primary key. Now coming to the create table reserves. Here the reserves table we are creating with the SID is the number of 3, BID is the varchar of 20 not null, day, this is also varchar something. Here it is the foreign key, SID is the foreign key and BID is the foreign key. Here foreign key SID refers the sailors, references the sailors. Now foreign key of BID references the boats. Here two tables are available here. The two tables SID and BID. Here in SID of reserves refers to the references the sailors, and coming to the foreign key of BID here references to the another table that is available which is available in the boats, that is also available here. Now this is about the relation between primary key and foreign key. Sometimes always foreign key references to the primary key. That way we are creating the relationship between one table and between the tables. Now coming to the insertion operation here, insert, which insert rows into the table. Some set of rows we are going to insert into the table by using the insert command. The syntax for this one is insert into table name. Table name is what the table we are using to insert the some set of rows we are specifying here. Here boats or sailors or something. Insert into table name, values, and then after the within the parenthesis we are specifying the column name one, column name to column, and then column values we are specifying here, and then finally ends with the semicolon. Now, for example, insert into sellers values for the purpose of the first one 22, some destined something 7 comma 45. These are the one here. By using this insert into command, we are inserting one row into the sellers. Next one is insert into value some, and then another row, second row we are going to insert here, also third row, and then the fourth row we are going to insert, and then some of the fifth row. Now this is about the some sort of two values are in two rows are inserted into the sellers table, and then two rows are inserted into the boards table, and another one or two rows are inserted into the reserves table. Now coming to the sailors, boats are some relations. Sailors is there. This is about the sailors relation, and then boats relation is there. Some set of values, and coming to the reserves relation, it is with some set of values. Here, sailors is the relation or table with the 4 columns. Reserves is the another table or relation with the 3 columns, and boards is the another relation with the 3 columns. Here in sailors, SID is there, and then coming to the reserves, SID is available, and then BID is available. Coming to the boards, BID is available. We can create the relationship between boards and reserves by using the similar name, that is BID. We can create the relationship between sailors and reserves by using the SID in sailors as well as SID in reserves. Here, these are the 3 tables which is completely related. Sailors to the reserves and reserves to the boats. Now this is about the, here one database is there. Here the simple database which contains 3 tables. Those are sailors as well as reserves and then boats. These are linked by using a single name. Here 2 tables, that means boats and reserves are linked with the BID, and the reserves and sailors are linked with the what is called as SID. Now this is way we are creating a project by creating a set of tables which are especially for that required for that project. With this we started with the SQL commands here. In that DDL commands we are discussing here, we discussed it here, and as well as some of the DML commands like insert command, which is used to create the some set of rows into the tables. Now that's all for the lesson 1 of unit 2.